thank you for having me, actually. A lot of what we have done and how we've gotten this far is function of the community. And I wouldn't be here without the support of Thai community. Folks we were funded by Nexus, which is, again, comes from the same roots. So thank you for having me, and I'll go over a good rendition of one of my keynotes, which has been quite popular. The notion that AI has been a dream for most of us, right? It's not just the first day. We've always known that we'll be here, but I didn't realize it'll be this big, this quickly, which is great. It's kind of going to change a lot of things. Well, the other thing, T.S. Eliot kind of really started with how we answer a question and then immediately start with the next question. So it's a continuous iteration cycle of how we refine our thoughts, and AI is really behind that. And one of the key concepts we have always focused on is time is the only non-renewable resource. So it's kind of the only resource that we're optimizing for. Speed and accuracy are kind of the coins of our space. Data is essentially one of the key aspects of the space. Right? Sort of AI without data is meaningless. So at the heart of AI is it's transforming your data to code. And in the 80s, we had expert systems, which became rule engines. So almost all the next 20 years, we built software which were based on rule engines. And now we're doing AI with statistical learning, right? And so we're now building statistical learning-based way of writing those rule engines. Instead of hand-coding those rule engines, we're essentially generating the code from data. So it's a compiler, essentially, taking data and producing code. So that's kind of the heart of AI, if you want to demystify it away from everything else. But then code by itself is not as useful. You want feedback. Did the code actually work? Did I predict accurately? If I predicted it well, did it mean well? So then the feedback is actually what you're really creating or forcing new data created from feedback. For an AI-first company, feedback loops is the heart of the system. You start with some data, but it's the feedback loops that lead to improvement. So you're quickly looking for users who can give you feedback. And a classic example is Stitch Fix. It ships clothes at your doorstep. If you didn't ship it back, it becomes yours. So you're forced to say, no, I don't want this, I like this, I don't want this, I like this. That feedback is forced on the end user. As a result, you build a very rich ecosystem, and that leads to like AI working for you. Feedback is gold. I mean, we know cash is king, but feedback is gold. But what about cash? So data monetization is actually really what we're after. Right? Everybody has collected lots of data. If you think about every time there's a data people complain of big data, for example, an AI revolution is right around the corner. That's how we got started in 2011. We knew that when people are talking about big data, the next big revolution will be AI. But what data to change, what data to monetize is kind of the heart of the problem today. Take a large business process in the customer cycle. Say if it takes 2 months for CBRE to give you an office space, can I make it 2 minutes or two hours? Right. So that's if it's an Airbnb or WeWork, it can be done in 20 minutes. So that kind of reduction of a very long business process to something short leads to monetization. Right. So if you're really looking for data monetization to business process optimization. The other key aspect of AI applications is to be able to create feeling in the audience, in the users. You want to have the users to have an emotional response to your application, because it's actually a little bit of disempowering when the app knows so much about you. You want to make sure that it actually is able to get that reaction from you where you can fall in love with the application. And that's why we like smart apps, right? So they're smart not just because they know all about us, but they're actually predicting very well and making us feel at ease. And design that ignores humans is going to be ignored, right? So packaging the AI application in a human-first design will lead to much better results. At the heart of what we think of AI is that it is condensing data to code. What does that mean? So if you have imagination and you have driven and you have a purpose and collect all the data sets for that problem, then AI could be your co-founder. because AI is actually reducing that, like the multi-step process needed to generate code for your application into a single one-stop solution. So that's why AI is actually really not just democratizing data, democratizing AI, democratizing data, and then comes democratizing ownership, because AI will actually lead to a lot more entrepreneurship across the world. And that's kind of how we see this space. There are several risks for AI at this moment. One of them is, of course, talent. Right? So we need to simplify this tool chain so we can actually make it much more simpler. Trust. AI is a black box today. How do we make it more explainable? How do we break apart the black box and interpret it much better? Hype. Right? So a lot of hype in AI right now. And AI winters came not because of AI didn't work. It came because there were over expectations for what was simply a mathematical construct. So I think we need to demystify it. So some of the things that we do is continuously work with customers, work with users, work with meetups, groups like these, and get people to play with AI tools and AI platforms, because it's actually quite informative, right? Sort of a lot of programs that we run, AI for all, AI for kids, where once you start infecting people with the ability to learn the AI toolchain, then it becomes much less of a mystery. And data is held by like a few companies in the world right now. And I think that's making open data. We had open AI. Fortunately, AI is now open. That was our vision. But I think data is not open. So I think that's the key piece, is how do we start democratizing data and civil rights, and data privacy as a civil rights is something we think about, talk about. We spoke to the California Bill of Rights, for example, where that was a big change. GDPR is a step in the right direction. But we think of data as something that everybody needs to own their data. And that way, you, instead of putting your precious jewels in the bank, you put your data in a bank. And that way you can monetize it or give access to it the way you want it. Then there's, of course, people and borders. There's a geopolitical war out there, and AI is playing a huge role there, right? Sort of if you think about what happened with our elections even. But China, for example, has some of the best AI platforms right now. Tencent and Ali and Baidu have some amazing AI talent. And I think that we need to bolster the AI movement in the rest of the world. Life cycle of data, I'm sure we've heard of this before. Insights need to become stories, and stories need to lead to wisdom. So how do we compress a lot of stories to simple wisdom? Data science ultimately is the pursuit of truth. So we are really continuously iterating to make data science better. One of the key aspects we find is that verticals, people think of themselves that they're in a vertical. But I think data has this capacity to be a horizontal. So instead of thinking you're competing within the vertical, you need to be protecting your brand and your community by using the data you have today and giving them tools and giving them data products that make their experiences better. So the heart of the matter is that code is a commodity and data has an expiry date. So if you don't use data that's the last 2 years, then you're not going to be able to use it forever. So that's the important aspect of the time aspect there. But verticals, most of the best discoveries in your vertical are going to be no longer useful in your vertical. You need to think horizontal to be able to monetize your data. The best way to think about this is this famous book from Where Are the Customers' Yachts? If your customers are successful and happy, then, if you think about, this is actually a 1929 book, one of Warren Buffett's favorite book. And the idea is that it's, if you think about the customer success, then automatically you find out which use cases to go after. We focused on making platforms and not just products. And we gave our first product, 100% open source product, to the community. And they say you give to get, and in our case, we got in spades. Our first product became a leader in the Gartner Quadrant, mostly because customers loved our product, and everybody else in the Gartner Quadrant actually are either a partner or use our product or use some variation of our open source product. And so that led us to some strong partnerships. Some of our partners will be speaking later today. But I think the raise of forest, not just a tree, was really, it's really exciting to see a platform for machine learning and AI. It never existed in 2012. The customers do love us, and that's actually something, it's kudos to the team behind the product and all the support. But really, the focus has been very much on customer satisfaction. We also believe that we have to make software, not just consume it. right? So as a result of that, we got a lot of people to experience the product first, then buy, and then continue to alter the product. So that's actually a bigger piece where the cycle of selling has no longer stopped at buy. You need to give customers the ability to reconfigure and make their own product. And that's true for our new product as well. So this is kind of the core theme behind. We have released a lot of open source products in the past, and built some strong partnerships in NVIDIA, IBM Power, and several data companies and customers. Data is actually a Sanskrit word. And datum became very popular in Latin in 1800s after the English came to the US in India. And actually it means to give, right? It means to impart knowledge, data, right? So there's nothing to, it's not foreign. Datum, yeah. So data is actually a team sport. And it's actually really difficult to get all of these in one place. In every edge of this, you actually have almost a conflict. When you have an algorithms guy working with a data engineer, there's a lot of conflict. And a mathematician and a software engineer, the math guy thinks of the software engineer as an applied mathematician, right? So they're really far down the chain. So I think that kind of collaborative work needs tool chains. At every edge of this, there's a tool chain to be built. And I think we have now started building some tools that actually help not just pass the algorithms, but the rest of the space here. But design, of course, remains really very, very intricate. Some of the things we're working on is how do we use AI to explain AI? And that's actually asking like kind of the elementary school teacher to explain how our kids are doing, right? So explainable AI is very interesting. Data scientists are obsessed with data, right? But boards are really obsessed with stories. So there's a natural transition that you need to make. And that storytelling is actually heart of what you can do with data. I'll give you an example. Let me put this one slide before I jump into an example here. Data scientists are powering strategy in your companies. And that strategy today is being automated. It used to be manual. Now you can automate it. So I'll introduce a product called Driverless AI, which empowers the data scientists to do a lot more. And produce pipelines in return. If you produce pipelines in return, you can then power applications straight out of the bat. So let me jump quickly to a little bit of product here. So here's some data sets. This is a credit card data set of the last few years of a Taiwanese bank. And we're trying to automate kind of visualization, for example. Here we're looking at outliers, and we're trying to see what kind of, what's the data look like, right, sort of at the heart of it. Again, so far we've done only aggregation, nothing fancy. Now I'm going to build a model and automate it in a way that you can actually take it to production. So we're trying to, who will default payment next month? And I want it to be reasonably interpretable. So I'm going to launch an experiment. And here on GPUs, this product is able to relentlessly build models, just like a real data scientist would be. It's actually essentially doing a bunch of feature engineering. Feature engineering is the idea that you can collapse some columns and create a net new insight that you can then use it to build strategy. So what it's doing is doing a lot of feature engineering first, then building a model using those features. So it runs a full-fledged model. Because of GPUs, this runs really fast, and then scores the model. So it's feature engineering, modeling, scoring, feature engineering, modeling, scoring, just like a data scientist would be doing. All the while, it is trying to optimize for accuracy of the prediction. So essentially, the day in the life of data scientist is to kind of improve accuracy. And so we have automated some of that cycles. And along the way, we prevented overfitting, for example, by using a reusable holdout set. We prevented leakage of test and train by making the cross-validation really slick. And so, or bulletproof in this case. So we put in some safety guards so that you can actually build those models very, very easily without having to learn everything about different math that's needed to build them accurately. Now, I've run one just before we started. This guy ended up producing some really sophisticated models. He ended up numerical to categorical weight of evidence, monotonically increasing. So he's actually build some sophisticated features, ran a lot of models, but you want to know how it was built, right? So then you can actually download the actual report and see, I want to know how this was built. So essentially, it gives you all the data set that was picked, what was the shifts involved, what was the methodology that it was used. We use a genetic algorithm, so it's called feature evolution, to evolve the features and create a report. So the lead data scientist, before it goes to the regulators, can actually analyze if did he use TensorFlow, right? Sort of all sorts of aspects of picking the right algorithm and right model, the validation strategy that was used. So eventually you can get a lot of and what kind of features eventually won. So that's kind of to give you an idea, the kind of transparency you want to bring to this process and how it ended up picking the best model. So that's one part. The other aspect of this that's very interesting is interpretability. So, excuse me. Interpretability is actually the idea that you can essentially go all the way and produce English PowerPoint from the model. And one of the things that very famously known, that Feynman discovered that the O-ring explosion was predicted, but was buried in the 9th slide and 4th bullet point. So most scientists will find interesting things, but it'll be like lost in the translation. So one of the things we wanted was actually print the exact reason why, the local reason why in this particular case, this guy has a balance limit of 330,000. So it's a pretty good balance. Sorry for the slide, the way it shows. It has a very big balance limit, so he has a great credit score. But he ended up using, 3 months ago, he ended up spending $365,000. As a result, he's very likely to default payment next month. So that's roughly the prediction it was trying to chase. So it's an interesting, so telling that kind of story from your data has impact. That's how business people will get the courage to deploy our models and act on them. And that's kind of the other aspect of the product. I mean, there are paths to talking about this even more. But I want to jump into what are the top AI-first design patterns, right? Decompose your app into lots of micro AI services. Now, if you decompose your AI services, you need to get agents to work with each other. Are they going to be collaborative? Are they going to be adversarial? Or are they going to be complementary? So depending on which technique you use, like GANs and others are adversarial techniques, you could use complementary AI services as well, which augment each other's intuition. And of course, and that's a very loaded statement, but there's a lot of interesting techniques for multiple AI agents working on a single app. Then the return on AI is as good as the data you have. So look for alternative data sources. We have another a new recipe that we've added where it looks for alternative data sources and augments your data with weather, for example, or augments your data with holidays or S&P 500 that day and so on and so forth. Automate as much as you can on the ML pipelines and try to build in as many feedback loops as you can, because safety is going to come through a feedback loop that comes back quickly. And trust, building trust is absolutely quite important. But try to make new data from your model, from your application. The new data is actually going to be the gold. One of the things that we produce, and I didn't probably talk about it earlier, is the experiments end up producing real pipelines, software Java code that you can then essentially deploy that with an API around it. So this is Java code or C++ code, or in some cases, like in healthcare, we produce Epic code. So you can then produce and deploy that into the application itself. This is what we call Mojo here, or it's actually a simple jar file. So that's kind of the, I mean, that's the kind of automation from models to code, and from code to deployment is roughly what we think of as the compressed cycle of building applications. AI is a compression cycle for building applications. Oops. I think it downloaded the Mojo, so I think you have the Mojo here. Well, wait a minute. I thought I had the sexiest job in the 21st century. The automation has definitely taken over. Right? Sort of, if you think about what we are doing, we built feature engineering, time series, and NLP. And those are the model recipes that we're continuing to build. Other players in the space are building vision or speech and other recognition, the consumer AI and AI that's dominant. So we're letting them do that, and we're essentially focused on the enterprise AI side. We think that the recipes can be authored by you as well. So end users have to make, not just buy. So that kind of theme is pervasive of this product as well, where people can add their own recipes. In the end, we think of this as data hack, lots of data hack scripts that can end up powering a understanding of different problems. We had some of the world's grandmasters in Kaggle, top 5. There are about 95 grandmasters in Kaggle, the data science competition space. We have half a dozen of them. And they are essentially building these recipes to make the models be as good as the best you can hire. So then it becomes less of a challenge of being able to hire the best data scientist and more about asking the big question. Once science becomes automated, it really empowers, right? So for last 500 years, science was the dominant force in the space. How do we now, then imagination and courage kick in as the next important pieces? Of course, we talked about this as civil rights. This slide is actually really about the best innovation in any vertical is really, so penicillin was an accidental discovery, right? So the best discovery in your space may not be useful for you, but it's useful for someone else. So that's kind of how we're building an exchange, which can allow you at the end of building the model, you can publish it into the cloud and then start monetizing your model. And I think this is going to be a good blueprint for the future ahead. We build, so in a nutshell, I think the efficiency of data science, when we say democratization, it's really about faster, cheaper, and easier. How do you make the access to it so easy that you cannot not use it? To make it so dead simple. And so then you can, if the cost of science is reduced, it becomes more accessible. So you can essentially make new mistakes because the cost of mistake is not so high. Companies like Amazon are able to do thousands of experiments because the cost of experiment is very low for them. And I think that's where we are falling behind, and hence we need to reduce the cost of making an experiment. Some use cases, obviously, there's lots of banking use cases. I was talking at the banking conference recently. Here are some customers who've been playing with our product. And here's some use cases from Capital One. So we started with fraud prevention and then eventually quickly graduated to credit risk scoring. We replaced FICO and other credit scoring engines with our platform. Eventually joined, focused on auto finance, and then KYC, anti-money laundering, some of the use cases, master data management. So as you can see, AI is actually quite extensively useful, not just one or two use cases, multiple use cases in any bank or any customer. So things can change. It's a money ball for business. It's sort of, people ask me, what is BI and what is AI? How do they differ? BI is about analyzing the past. AI is about analyzing the past and predicting the future and betting on how much it will be. So you're looking, usually you produce scores and data products. In BI, you get charts and reports. I think we've kind of covered most of the pieces. I'll talk about some other powerful use cases like collision fraud prevention. In this particular use case, they took a graph database, converted it to Node2Vec, and then powered it through Driverless AI. The feature engineering gave about 95% accuracy, about the same that took about 10 data scientists 10 man-years to produce. So it's a real compression in cycle. The team H2O is really, I'm the front end for a very amazing team behind me. We started compilers as compiler systems guys and worked closely with the math department in Purdue and Stanford and Berkeley, and then added some great physicists. Eventually, we got data scientists use our product. About 100,000 data scientists use our product, if not more. Today, it's open source is deployed at 12,000 companies. And then we hired a lot of grandmasters who were really triggering the domain, and that led us to now seeking domain experts, both at customers and inside. One thing we learned is that, of course, as we continue to iterate, we find a lot of really great things, and we're quite grateful for all the community help there. I'm going to add a couple of more slides here to talk about things to learn. Learning is fun. This is my mom's favorite slide. 7 things to learn from a thief. And to work at night when everybody is asleep. If you cannot finish on the first day, then go back. I like this one best. To withstand all kind of beatings and tortures, but still do what you want to do, which is AI, right? And to believe that your work is worthwhile and not be willing to change it, right? And I actually like number 5 too. They acquire the most expensive things and sell it at 1/10 the price, right? It's amazing. This is my favorite book recently I've been reading. So this is actually there are probably not as many love letters written to his wife by anyone that are so publicly available. This is amazing. And my wife is she was my true co-founder. So I like this quite a bit. Here's actually one thing he writes to, Dear Cecil, I need rupees 150 rand for my studies. May I exploit you? This is the first line of his letter, right? I thought after reading this book, Gandhi had an easier job to fight for freedom than Nelson, because he actually was inside the prison while he was fighting the whole time. This actually, thank you. There are lots of great speakers after this, and I tend to think of this as one of those things where we've learned a heck of a lot from our culture, which is very mathematical in nature. So I'll play a small snippet of the song. As most of you know, the meaning behind is that there's so many great people who are assembled here. Thank you for all of them and the ones who came before us, because of which we're able to do this. The dot, of course, is perfect, and the 0 to 1 transition, some of you have read the book 0 to 1 from Peter Thiel. This has been there for us for centuries, and I think India is an amazing country for that kind of background it gives us to think about stuff mathematically. A lot has come through sacrifice, and sacrifice of not just us, our families, but the rest of the community. And we think of silence. Silence is actually much more powerful than words. And the only thing that comes between silence and words is actually music. And music can actually truly express, the second best way to express is music. And mathematical music, Shastri Sangeet is actually Indian music, and Shastriya means mathematical. So as a culture, we are bent on doing math and thinking about philosophy. And I think AI really is all about math, mathematically thinking about data. And this math and data both being our culture, I think AI and data would be powerful for most of us and very fulfilling. And I think that's kind of roughly what Aldous Huxley was expressing here, talking about feeling. And I think people are focused on return of investment. Return on emotion is just as important. The only thing that is, so usually they say less is more. The only place where more is more than less is in emotions. If you can, more of emotions, we need more of love. And I think that's really what we think. When I started, the time is the only non-renewable resource. Love is the only renewable resource. And with passion, you can break any barrier. So I'm hoping I can inspire a few people to do that more. So thank you so much. I think I ran over.
Thanks, SriSatish. Thank you very much.